All right, in this video, we're going to talk a little bit more about Unit 4 discussion. So it says you have a box containing 10 ping pong balls, 5 are green, 5 are blue. The green balls are numbered 1 through 5, the blue balls are numbered 1 through 5. You play a game where you choose one ball at random. If the ball chosen is green, you win $5. If the ball chosen is a 3, you win $50. If the ball chosen is both green and a 3, then you win $10,000. So the rules of probability will tell you on this game here, um, if the ball is chosen as green, well, there's 5 green balls and there's 10 total, right? So the probability that you would choose a green ball is 50% on this one, right? Just using the laws of probability, 5 green over 10 total. And on this one, if the ball chosen is a 3, you win $50. So that is going to be there's two threes, right? One green and one blue. So there's two with that are numbered 3 out of 10 total balls. So that's 2 out of 10. That's around 20%, right? If you convert that to decimal, well, that is 20%, right, as a decimal. And if the ball is both chosen as both green and 3, then you win $10,000. So that there's only one of those, right? There's only one ball that's both green and labeled with a 3. So that would be 1 out of 10. So that's 10% chance on this one. So that's what the math says, right? It says 50% on this one, 20% on the 3, and then 10% on the green and the 3. If you keep playing that game in the long run, that will be. So this code file that was attached, right, with um, a discussion for just kind of does simulations of that, right? So we'll just run through these 3 experiments a bunch of times, okay? And so you can do that at the run all button. Just click run all and it will generate a run. What controls how many times this gets done is this repetitions down here. So you can see the default is 10,000 on this one. So what it did was 10,000 repeated experiments of drawing a ball and looking at and seeing if it's blue or green. Okay, and here are the results, right? And you can see blue and green. And then here is sort of a summary of that, right? Um, and if you look on this bar chart, it says number of $5 winners is 4,982. That's out of 10,000. So the probability of winning $5 empirically, based on our simulation results, is 49.82. So you can see that's close to what the math says it's going to be, but not quite, right? Because remember, this is a random process. We're just kind of randomly doing this. So it's not going to be, you're going to have some runs where you lose more than you win and so forth. So out of 10,000 tries, it's not going to be exactly 50% every single time. Sometimes it's going to be a little more, sometimes it's going to be a little less. If you get really unlucky, right, then it might be, or really lucky, it might be a little bit more or less than it normally is off of this 50%. However, that shouldn't happen very often, right? So that's how this works. And then here we can see the results for the drawing of the number 3. You can see we got 20.13% on this one. And on the drawing just the green one and 3, you can see that we're around 10.12%. So at 10,000 repetitions, that's pretty close to what the math says. Okay. So on the questions, it says vary the number of simulations in the given code. So you would just go here, right, and then um, change that line that I showed you there before about repetitions. It's somewhere up here. Yeah, right here. So you can make it less or more. So I'm going to go with 100 and see what we get. So this will repeat 100 times. And just click run all and it will run those for you. And then you can see the results here. So here, right, we were 46% on this one. Remember the math said 50 on that one. On this one, we're at 17. Okay. And remember the math said 20% on this one. And on this one, we're at 7%. So remember the math said around 10% on this one. Okay, so that's what they want you to do. So go in and vary those number of simulations, indicate clearly what your changes do to the codes, include screenshots to illustrate your explanations. So you could just, I would just screenshot these results so you can see. So at 100 times, and just give these screenshots of these winners and losers parts right here, or just you can summarize it in a table or whatever, however you want to do that, that's fine also. But if you don't feel like making the table out, you can just screenshot these and indicate what they are. And then interpret the results based on the number of simulations that you choose. Indicate the number of winners and the probability of winning for each scenario. So that would be indicated on those screenshots there. You can show that through those screenshots. So I would screenshot those bar charts and then the one with the ones that have the statement down there below. So that's basically part number 3. Are your results more reasonable using smaller number or a larger number of simulations? So I would just do, one with a smaller number and then one with a larger number, larger than 10,000, which was the default value. So just crank this up to something larger than 10,000 and see what your results are. Okay, and then just a little paragraph about, what the results are on there. All right, so that's it on discussion 4. If you have any other questions at all, don't hesitate to shoot me an email or text.